Okay, today we're going to be talking about something called the law of cosines. And in the last video, we talked about the law of sines. And we used the law of sines to solve triangles that were not right triangles that were of the type angle, angle, side, angle, side, angle, and side, side, angle. Today, with the law of cosines, we are going to be using that to solve two other types of triangles that are not right triangles: side, angle, side, and side, side, side. So let's jump in here. It's a pretty straightforward formula. We're not going to go through the proof of it, but you can see that they use the Pythagorean theorem to get this particular equation here. And so first example is of a side, angle, side triangle. So we will draw this triangle here. And we will label it, and we will say A, put angle A right there, and across from angle A, we don't know angle A, but across from angle A, we have side A, which is 11, and then across from angle B, we have 5, so we'll call that 5, and we'll call that angle B, and we know that angle C is 20, so we'll put 20 degrees right there. And so we don't know side C, we don't know angle A, and we don't know angle B. So we're going to use this number 3. We'll use formula number 3. C squared equals A squared plus B squared minus 2AB cosine of C. And so we have C squared equals 11 squared, which is 121, plus 5 squared, which is 25, minus 2AB, so A is once again 11, and B is 5, and cosine of 20 degrees. And we can plug all of that straight into our calculator, all in one step, and we will get C squared equals 42.64, we'll say. And square root of that, so C is approximately 6.5. So we'll plug 6.5. Now make sure that you are using your calculator and you're working through all these calculations yourself. All right, so now we're going to find angle A. Now this brings us to something that's extremely important. So I'm going to put asterisks by this, and I want you to also on your notes put asterisks by this because this is extremely important. Extremely important. All right. When you have a choice between using the law of sines and the law of cosines to find a particular angle, always use the law of cosines because it will distinguish between acute angles and obtuse angles. Now let me explain that. When we did inverse trig, we remember that inverse sine only gives us angles back in quadrants 1 and 4. Well, let's just think about what type of angles are in quadrant 1. Quadrant 1 goes from 0 to 90. Those are all acute angles. Quadrant 4 goes from negative 90 to 0. Those are all acute angles. You notice there's no angle that's above 90. So what if angle A, which it looks like in this triangle, is an obtuse angle, an angle bigger than 90? Inverse sine will never give us an angle back that is bigger than 90 because of the quadrants that it operates in. However, inverse cosine, if you remember, gives you answers back in quadrants 1 and 2. Well, what type of angles are in quadrant 1? Quadrant 1, we have acute angles. And quadrant 2, we have obtuse angles, angles bigger than 90. So guess what? If angle A is really indeed an obtuse angle, inverse cosine will give it to you. If it is acute, inverse cosine will give it to you. So I want to caution you when you have a choice between law of sines and law of cosines to find an angle. Even though it may be easier to use the law of sines because it's a simpler formula, resist that temptation, and I want you to use the law of cosines for that. So we're going to use the law of cosines, and let me erase all of this so we have some room. And we are going to use the law of cosines in order to find angle A. All right, so angle A, we're going to use the first formula up here. So A squared is going to be 11 squared, so that'll be 121 equals B squared, which is 25, plus C squared, which we can use this right here. That'll be 42.64 minus 2 BC. B is 5. C is 6.5. And cosine of A. All right, so we need to do a little bit of math here. If we move some things around, we will get 121 minus 25 and minus 42.64. When we subtract all of that, that's going to give us 53.36. Once again, I want you to work this out on your own. Equals, now 2 times 5 is simply 10, and 10 times any number moves the decimal 1 to the right, so 10 times 6.5 is just going to be 65. So it's going to be negative 65 cosine of A. Divide both sides by negative 65. Divide by negative 65. And we're going to take the inverse cosine of both sides, and voila. Indeed, when we take the inverse cosine of that number, we end up getting 144.8 degrees, which indeed is an obtuse angle. I want to once again repeat, if you used the law of sines, you would not get that. You would get an acute angle, and it would be wrong. So we've got angle A, and so we can put that in here. That's going to be 144.8, and now we can add that with 20 and subtract it from 180, and so we will get angle B to be approximately 15.2 degrees. And so now we have all 3 angles and all 3 sides, and we have solved this triangle. All right, in this next example, we have a side-side-side triangle. So we have no angles. So that means we need to find 2 of the angles and then subtract those from 180 to get the third angle. So we'll draw this triangle out here. And let's label it. Let's see, the biggest side is A. So we'll make this angle A, and across from angle A is 9. And it looks like the next biggest side is B. So maybe we'll put B there, and across from B is 7. And angle C, across from angle C is the smallest side, 5. So it doesn't really matter where you start. I'm going to start with angle A, and so we're going to use this formula right here. And so A squared is 9 squared, so that's going to be 81, is equal to B squared, which is 49, 7 squared, 49, plus C squared, which is, so nice, real easy numbers, 25. And that's going to be minus 2B, which is 7, and C, which is 5. And once again, we don't know angle A. That's what we're looking for. So we have 81 equals 49 plus 25 is going to be 74. And minus, well, 5 times 7 is 35, times 2 is 70. Cosine of A. Subtract 74 over to the other side, and we get 7 equals negative 70 cosine of A. So divide by negative 70, and we get negative 0.1. So cosine of A is equal to negative 0.1. Inverse cosine of both sides to get the angle. And so angle A is going to approximately be 95.7 degrees. And so now we're going to do the same exercise with angle B. And so angle B, we'll use the second formula as well. And so angle B, so we'll just draw a little line here to separate our work. So angle B, so we'll say B squared, which is 49, equals A squared, which is 81, plus C squared, which is 25, minus 2 AC. A is 9, C is 5, cosine of B. Running out of a little space here. And to save time on this video, I want you to work this all out and make sure that you can get the answer. But angle B is going to be 50.7 degrees. Add that to 95.7 and subtract it from 180, and you will get angle C to be 33.6 degrees. And that's how you use law of cosines on a side-side-side triangle. All right, in this next example, we have a parallelogram that has sides of 18, 26, and an angle of 39, and we want to find the shorter diagonal. So we'll draw a nice parallelogram here, and take that over here. Parallelogram. Not the best looking parallelogram, but you get the idea. And so the shorter sides are 18 and 18. The longer sides are 26 and 26. Now we have two diagonals. We have one that is longer than the other. So that one would be this one. But they don't want us to find that one. That is the longer one. So I'm just showing you that that's one of the diagonals. But the one they want us to find is the shorter diagonal. And that is going to be that side right there. All right, so we have an angle of 39. So we know that that is 39 degrees, not that, because that is an obtuse angle. So this is also 39 as well. And so look what we have. We have a side, angle, side, triangle, and we can use that to find the length of the shorter diagonal. So maybe we'll call this A, B, and C. So this is going to be side A. And so once again, this is pretty simple. We're looking for side A. So we're going to use that first formula. So it'll be A squared equals B squared, which is 26 squared, plus C squared, which is 18 squared, minus 2 times B and C. So that's going to be 26 and 18, and cosine of 39 degrees. Type that all in your calculator. Don't forget to take the square root, and you will get side A to be 16.5 feet, and that would be the length of the shorter diagonal. All right, the next thing we're going to learn is a new formula to find the area of a triangle. And so let's say we have this triangle, and we'll call this triangle ABC. So we'll call this triangle A, B, and C. And we are going to draw a height that comes down here, and we'll call that H. And we know that the formula for the area of any triangle is base times height divided by 2, or some people write it as 1/2 the base times the height. All right, so the base of this particular triangle is the letter B. And so if we break this up into two right triangles, let's say we have this height right here, and we want to replace that height with something that is equal to that height. So we have a right triangle to the left, and why don't we say the sine of angle A is equal to the opposite side, which is H, over the hypotenuse, which is across from angle C, so that's little c. So now if we multiply both sides by C, we get H equals C times sine of A. And now we can take this formula right here, and we can plug it into our formula for the area of any triangle. And so that gives us a new formula. Area of a triangle is equal to 1/2 base. In this case, our base is the letter B, but in your triangle, it may be a different letter. So in this case, our base is B, so we'll put B. And H, we are replacing with C, sine of angle A. Now we have a new formula that we can use for any side angle side triangle. Notice you need two sides, B and C, and the angle between the sides, which would be A. You could also have A and B, sine of C, or A and C, sine of B. But the key is you must have the two sides and the angle between the sides. All right, in example 4, it says find the area of a regular octagon, and they tell you what that is. That's 8 equal sides and 8 equal angles inscribed inside a circle of radius 9 inches. And so at first you may say, well, do I need to find the area of this entire octagon? Not necessarily. What you really need to do is you need to find the area of one of these triangles and then multiply it by 8 because there are 8 equal triangles here. So let's just say we will take this point here, and there's one side of the triangle. There's another side of the triangle. And we know that the radius of the circle is 9, so we'll put that there, put that there. And the biggest challenge here is finding the angle. Well, if there's 8 equal angles, and we know that an entire circle has 360 degrees, then all you really need to do is divide 360 by 8, and you'll get 45 degrees. And so this triangle has a 45-degree angle inside. So once again, we have a side angle, side triangle. We can use our new formula for the area of a triangle. And so that is going to be the area. Doesn't really matter what the letters are, so I'm not even going to worry about using the letters. It's the multiplication of the two sides. So 9 times 9, and sine of the angle between the sides, which is 45 degrees. So this is going to be 81, and the sine of 45, we may remember from the unit circle, is, well, you could either write it as 1 over root 2 or root 2 over 2. So I'm going to write that as root 2 over 2. And a lot of students will make a mistake right here because they will think that they're done. But remember, it's asking us to find the area of the entire octagon, and we've just found the area of one of the 8 triangles, so we need to multiply our answer by 8. So we're going to multiply this by 8, and 8 and 2 cancel out into 4. So we have 4 times 81, and let's see what that would be. 81 times 4 is going to be 4, and then 4 times, so 324. So the area of this octagon is going to be 324 root 2. And that is, looks like inches squared, because we want to be good mathematicians and put units on our answers. And there's the area. All right, in this last example, we have a new formula again, and it is called Heron's formula. And Heron's formula basically allows you to find the area of a triangle when you have 3 sides given to you and no angles. So if you have a side, side, side triangle, so let's put that up here. Heron's formula is used when you have a side, side, side triangle. And so you can use this formula. Now the formula is the area is equal to the square root of S times S minus A times S minus B times S minus C. A, B, and C are the lengths of the sides, and S is something new. It's called the semi-perimeter, which is half the perimeter. So let's find S first. That's your first goal. First goal is we want to find S. So S in our problem is going to be 13 plus 15 plus 18 divided by 2. So 13 and 15 is 28, and 28 plus 18 is 46 divided by 2. So our semi-perimeter is 23. So now we're going to use our formula. So the area is equal to the square root. Now, don't forget this S in front here. It's easy to forget that. So it's going to be 23 times 23 minus A. It doesn't really matter the letters, so we'll put 13. And then 23 minus 15. And 23 minus 18. So we'll clean this up a little bit, and we get the square root of 23. 23 minus 13 is 10. 23 minus 15 is 8. 23 minus 18 is 5. So we multiply that all out and take the square root. We get approximately 96 square units. So 96 units squared. And that's how you use Heron's formula. Pretty simple formula for side, side, side triangles if we're looking for the area.